Okay, here we're just going to use a few things we know about logs. It tests that whether you know that if you just write log, it means log base 10, and ln means log base e. There's a couple that we're going to need to use a calculator for, so we're just going to evaluate it to 3 significant figures, but most of them are non-calculator and just involve the interpretation of logs. So if we start with part A, it's asking for log of 1 over 10. So that means log base 10 of 1 over 10. So it's basically what that means. I don't expect you to write this when you're actually doing it, but I'm saying log base 10 of, then think of 1 over 10, well that's 10 to the power minus 1. So it's saying what power do I raise 10 to in order to get 10 to the power minus 1? Well, if you want 10 to the power minus 1, you're going to have to raise 10 to the power minus 1, so the answer is just minus 1. Part B, log of root 10, log root 10. So that's saying what power do I raise 10 to? So log base 10 of, well, root 10 means 10 to the power half. So it's saying what power must I raise 10 to in order to get 10 to the power of a half? Well, that's clearly 1/2. Part C, log 1. Log 1. So that is saying it's log base 10 of 1. So it's saying what power must I raise 10 to in order to get 1? So it's kind of saying 10 to what power equals 1? Well, if you want to get to the power 1, you need to raise 10 to the power of 0. So if you want to get 1, 10 to the 0 will get that. So the answer is 0. Part D. 10 to the power log 47. 10 to the power log 47. So then this is testing, do you know what log means? What a log is? So this is saying we want to raise 10 to the power. We need to raise 10 to the power of the power you raise 10 to get 47. So the log 47 bit says what power do you raise 10 to in order to get 47? That's the answer to log 47. So then if you raise 10 to the power 47, then you achieve 47. So the answer is just 47, because it's what power must I raise 10 to in order to get 47, and then you actually raise 10 to that power. So it achieves 47. It does get you to 47 if you do that exact thing. Part E, log 50. So if you look at this, it's saying what power do you raise 10 to in order to get 50? So this is not a non-calculator question. There's no obvious power that you can raise 10 to get 50. So I'm just going to go to the calculator and just type it in. You see, log 50, and that gives me 1.698. So we're going to go 1.699. 1.699 to 3 significant figures, and that was just using the GDC. Part F, ln e. So now we're into different logs. So ln e. Remember, ln means log base e. So we're saying what power do I raise e to get e? Well, if you want to raise a number to a power to get to the number, you need to raise it to 1. But e to the power 1 equals e. So the answer is 1. Should have put the box around that. Part G is ln 1 over e cubed. ln 1 over e cubed. So that is saying, well, it's log base e, and 1 over e cubed is e to the power minus 3. So it's log base e of e to the minus 3. Again, as in working out for the exam, I wouldn't expect you to write log base e. I'm doing it so I can explain to you. So this is saying what power must I raise e to get e to the power minus 3. So if I want e to the power minus 3, I need to raise e to the power minus 3. The answer is minus 3. H, ln 1. So this is very, very similar to C. In fact, it's incredibly similar. It's a different base, but the answer is not going to be any different. it's saying basically e to what power equals 1. Well, that means e to the power 0 equals 1. The answer is just 0. In fact, any log in any base of 1 is always going to be 0. I. E to the power of ln 5. Again, this is very similar to this part D when we had 10 to the power log 47. This is saying the ln 5 bit says what power do we need to raise e to get 5? So that is an answer. Then if we actually raise e to that power, then that's exactly where we get to. The answer is 5. I'll just say it again. So I know I sound a bit like a broken record, but I do think it's important. It's saying you raise e to the power you need to raise e to in order to get 5. If you do that, you will get 5. J, ln 50. ln 50. Again, this is very similar to part E in that I don't know what ln 50 is. There's certainly no way I can turn e into 50 just using nice powers and roots. So I'm going to go to the calculator. You see ln is right next to log. I'm just going to press ln 50. Execute, and that is 3.91 to 3 significant figures. That was using the GDC, and actually now I've looked at that, I've just realised that part E did not, that was just 3 decimal places, which would be poor. So let's change this to 1.70.